Hey guys, so in this video, we are going to go over all of the formulas for how you find the area of these 5 different types of shapes. So you'll notice I have already kind of drawn the shapes on the foldable that you were given. So the first part of this video is making sure your foldable is set up. So essentially when you're given this foldable, it should have had all the flaps kind of already cut. So what you need to do is you just need to fold along this dotted line, the flaps. And they should reach towards the center line on your paper. If they don't reach all the way, that's okay. Just fold them along that line as best you can. So essentially, once you fold all of your flaps that are already cut, what should happen is it should be a foldable that kind of looks like this, where it's all folded and you have these 8 different flaps. So go ahead and take a moment to do that. If you want, you can pause the video. I'll give you a couple moments. Okay, and the next thing you need to do is you need to start labeling your foldable with the different kinds of shapes. So the 5 shapes that we're going to be working with are a square, a rectangle, a triangle, a parallelogram, and a trapezoid. So on 5 flaps on the front of your foldable, it doesn't matter what 5 flaps they are. I just kind of started from the top and like labeled the first 5. The other 3 we are going to label eventually. We're just not going to do that in this video. Go ahead and draw the shape as best you can. It doesn't have to be perfect. It's your foldable. You know, like when you draw a square, if it's supposed to be a square, you know, when you draw a rectangle, it's supposed to be a rectangle. But draw all 5 shapes: a square, a rectangle, a parallelogram, which kind of looks like a square, but like we smushed the corners, a triangle, and a trapezoid. So go ahead and draw all 5 of these shapes, and I would go ahead and label the front part of the flap. So I will give you a couple moments to do this. I will move my hand so that way if you want to just pause the video and copy what you see here, you can do that now. Okay, and once you have all of the front labeled, you can completely open up your foldable all the way. And I want you to do kind of what you just did, but I just want you to draw the shape on the back side of the flap. So on your square flap, draw a square, but don't label anything on it. Just draw a plain square. On the parallelogram flap, draw a parallelogram just on the back side. On the trapezoid flap, draw a trapezoid just on the back side. Same with the rectangle and the triangle. So I will pause the video right here. Or I won't pause. You could pause the video right here. So that way you can copy what you see. Okay, so now that we have the 5 shapes drawn and for the most part labeled on the front, we're going to label them on the inside with their different parts. So we're going to look at each shape. We're going to talk about what are the parts that compose of that shape, and then we're going to write down what the formula is to find the area or the space kind of enclosed within the perimeter or all the sides of each shape. So we're going to start off with rectangles and squares. I say let's start out with squares first, because squares tend to be the easiest to work with. So in a square, we have 4 sides. All of the sides are the same measurement. So I'm just going to label all the sides with the letter S. You may see when you get into more intense geometry, if a shape has like a little line intersecting all 4 sides, that means that like these parts or these sides of a shape are all congruent or equal to each other. So in a square, like all sides are the same length. So when we find the area of a square, all we do is we multiply the sides together, but we only need to multiply 2 sides together. So the area of a square, the formula is we multiply one side times another side. So since all the sides are the same, we're essentially multiplying the same number times itself. So another way you could see this formula is we could take the sides, whatever the measurement is of one of the square sides, and square it. When we multiply the same thing times itself twice, that's the same thing as squaring it. So the area of a square is just side times side, or the sides squared. Now, a rectangle, on the other hand, if we go across the way, a rectangle is similar, except the sides on a rectangle are not necessarily congruent or equal to each other. So in a rectangle, we typically think of the longest side. This is the length, which we could label it with the letter L. Or from that previous video, the bottom side of the shape, we typically call the base, which we label with the letter B. So it could be a capital B, it could be a lowercase b, it's up to you. So the length or the base is typically the bottom or the longest side. And then the shape's height, we could call this the height, or something else that you may hear is width. So we could say this is the width of the rectangle, or we could say this is the height of the rectangle. And like a square, all we're going to do is we're going to multiply the two sides together to find the area of the entire rectangle. So if we use length and width, we could say area is equal to length times width, or we could say area is equal to, if we use base and height instead of length and width, we could say base times height. Now, sometimes you might see the letters right next to each other. So remember, anytime a letter is right next to each other, it means to multiply. So these two formulas essentially mean the same thing. If you want to say length and width versus if you want to say base and height, it's the same thing, but that's all we need to do when we find the area of a rectangle. In a triangle, we'll kind of stick over here on this side. We are going to need the base and height of a triangle. The base of a triangle, again, is typically what we see as the bottom side of the shape. Like if this triangle was like standing up, if we had a flat shape standing up, this would probably be the one that's like level with the table or the ground. So we say this is the base. And then the height is the distance from the top part of the shape to the bottom part of the shape or to the base, but it typically makes a perpendicular angle, or it makes a right angle. So in a triangle like this, we're just going to measure from the top point in a straight line all the way down to the base. This should be forming a right angle. And this is the height of the triangle. This is the height of the triangle. And I used a dotted line instead of a solid line. So that way, you know, like this is not an additional side of the shape. I'm not splitting this triangle in two. I'm simply measuring the distance from the top and the bottom. So when we find the area of a triangle, we are going to take our base and our height and we're going to multiply them together. However, unlike a square or a rectangle, we're also going to take half of that amount. If you think about a square or a rectangle, if you cut it diagonally, like if I drew a diagonal line from this corner to this corner, I am essentially making two triangles within my particular rectangle. And same thing would happen if I like scooted over there and did that with a square. So base times height gets that total area of a rectangle. Base times height, but then half of that gets half that area of the rectangle, which is the same amount as the shape of a triangle. So we say base times height and then take half is how we find the area of a triangle. Another way that you could write this formula, if you don't like fractions, well, I'm kind of going to give you another fraction, but I'm going to give you a fraction in the terms of meaning division, right? So we could take base times height, and you could put the division sign and put divided by 2. That's fine. Or you could write it like this, base times height divided by 2. That also works. Essentially, we're taking our base times our height, and then we're taking half when we find the area of a triangle. So we plug in our two measurements for our base and height, and then we multiply them together, and then we divide it by 2. A parallelogram, we're going to kind of go back over here. Okay, a parallelogram is similar to rectangles and squares in a sense that it has a base and it has a height. So typically that bottom part of the shape we would label as the base. Height is from the top point or top base. In this case, we don't really have a top point of our parallelogram. We have like a base. So we just want to measure it. I kind of like to pick like one of the corner points and just measure a straight line. Not the straightest, but straight-ish. If we measured a straight line that formed a right angle with the base, that measurement there, that is the height of a parallelogram. And a parallelogram, because it's a four-sided shape, it's still the formula of just taking the base times the height. So all we do is we multiply the base times the height. to find the area of this particular parallelogram. We want to make sure we don't confuse the height with one of these side length measurements here, because although those seem like they would be the same distance as the height that we drew, they're angled kind of differently. So that's not necessarily the case. The height is the distance from where the top of the shape is to where the bottom base of the shape lies. That measurement right there, and it has to form a right angle with the base. The last shape, a trapezoid, this I would say is the most complex out of the shapes that you're going to learn about today, because I hope at least squares and rectangles, maybe even parallelograms, I hope these are a review. And triangles, all it is you do base times height, just like all the other shapes, but then you take half. Trapezoid, there's kind of a third step that gets involved, because in a trapezoid kind of splits itself. If I draw the height of a trapezoid, that's kind of what I'm drawing. A trapezoid kind of splits itself into, let me zoom in. It splits itself into two triangles and a rectangle here. So we could find the area of this rectangle, add it to the area of this rectangle, find the area, or not rectangle, I'm sorry. We could find the area of this triangle, find the area of this triangle, and then add it to the area of this rectangle to find the total area of a trapezoid. But thankfully there's a formula that kind of does all that work for us. The formula is this. I'm going to write the formula down, and then we'll kind of go over where the parts are on the trapezoid. So the formula is 1/2 times one of our bases. So we say base 1 plus base 2. So essentially what this means in here is we're adding our bases together times the height of a trapezoid. So you may be like, whoa, this looks confusing, but it's just kind of 3 steps. And here are where all the parts are on the trapezoid. So in a trapezoid, we have a bottom base and a top base. So we just label them B1 and B2. If you don't like using B1 and B2, if you want to use like 2 different letters, like you could use like, this is base B and this is A, or this is C. You can use a different variable to represent the top base. It doesn't matter if we labeled like the top one base 1 or the bottom one base 1. It really doesn't matter, because essentially when we find the area, all we're going to do is we're going to add these 2 measurements together. That's what's happening here. And so it doesn't matter if we add, you know, base 1 plus base 2 or base 2 plus base 1, like either way we'll get the same answer. So we're going to add our bases together. That's the first step. Okay, then we're going to multiply by the height of the trapezoid. The height of the trapezoid is that distance from the top base to the bottom where it forms a right angle. So these 2 kind of dotted lines here that I drew, they're the same measurement. That's the height. We're going to multiply times the height, and then we're going to take half. We're going to take half at the very end of that. So another way we could think about taking half is we could do our base 1 plus base 2 times our height. And then we could divide the whole thing by 2. When we take half, we divide by 2. So these are the formulas for all of the main shapes that you're going to be working with. The good news is you don't have to memorize these formulas. They will always be given to you from now until the end of time when you work with shapes. On your STAR test, they'll be given to you. On your algebra placement test, when you take actual geometry, maybe in 8th grade or 9th grade, they will always be given to you. But it's important to kind of see where they form and where they come from. And when you use the formula, all you do is you essentially take this equation and you plug in the variables that you're given. So if you're given your base 1, your base 2, and your height, you plug them into the formula and you solve the formula essentially like a PEMDAS problem. You'll add your 2 bases together, multiply by the height, and then take half, and you'll get what your area is equivalent to. I forgot to put my equal sign right here. Same thing with all the other formulas. All you do is you plug in the different parts of the shape to the formula and you solve it just like a PEMDAS problem. You're evaluating the formula equation to solve for the area. So make sure if you need to go back and double check any of the parts of the shape or anything like that, you know kind of where the different parts of the shape are, because sometimes they may not give you a picture. And so sometimes it's really helpful to draw a picture when you're working with area and perimeter and geometry, and keep this foldable handy. So that way, when you work on your practice problems or homework, or if I let you use it on a quiz or a test, you have it handy so you can always reference the formulas and where the different parts of a shape are.